In the last lecture, we were talking about introduction of new products and services, and we had identified various aspects that should be considered in that analysis. For instance, you would recall that we had looked at the marketing aspect, the product characteristics, the aesthetic aspect, the production aspect, and we had indicated that perhaps the most important aspect is the economic aspect. So the evaluation of the economic aspect in introducing new products and services is the theme of today's. In this lecture, we shall look at what particular financial criteria are relevant for evaluating new product and service launch decisions. And we'll also see how different kinds of economic analysis can be conducted to find out what is best from amongst various products, and also to find out what could be done with reference to individual products to improve their profitability. One can broadly talk about two kinds of economic analysis. The first kind of economic analysis we have already talked about, which is gross measures of cash flows. These are extremely important because what we try to do here is look at the entire life cycle of a product and estimate the cash flows over the entire lifespan, and then measure the worthwhileness of the cash flows in terms of computations like the net present value, the internal rate of return, or the payback, which are all essentially measures of return or the performance of the cash flows over time. Another important thing that can be done with the cash flow analysis is finding out the loan disbursement capability, which means essentially to find out whether the cash flows are adequate to return a particular loan. So financial institutions typically are interested in this kind of analysis, and a figure called the debt service coverage ratio is something which can be computed from the cash flows to determine what is the loan paying capability of a particular investment. Then apart from this, we can be talking about risk evaluation in probability terms. This is something, for instance, that we did with our decision tree analysis, where you can identify the quantum of risk involved through subjective probabilities with various options and with various outcomes of a particular decision. Now, apart from these, when one is talking about economic analysis, one can talk about annual measures of performance. And in this category, things that are important are the characterization of costs into fixed and variable costs. Fixed and variable costs essentially depend upon a bifurcation of costs into the categories that do not depend upon the production capacity and a category that does depend upon the production capacity. So if you can do this, then you can do some very useful analysis. You can talk about break-even analysis. You can talk about profit volume charts for products, because profit is one of the major parameters that the management may be interested in. You can also investigate the effect on the profit of changes in demand, changes in profitability, and all this analysis can help us in determining the optimal strategy evaluation. So essentially, in this lecture, our focus is going to be on these measures of performance for new product and service appraisal. just to recapitulate, when we are talking about gross performance measures, our input is essentially the stream of cash flows. So we know what is the investment, what is likely to be the return in the first year, the second year, and so on over the entire planning horizon of the product or the service, and this stream of cash flows is generally used to derive a number of important financial parameters like the net present value, the payback period, the internal rate of return, and a variety of financial ratios like typically we might have a benefit to cost ratio, or we might have the debt service coverage ratio. So a benefit to cost ratio would tell us the quantum of benefits over the entire lifespan divided by the overall cost. So if this ratio is greater than 1, only then would a project be worthwhile. And similarly, we are talking about the debt service coverage ratio, which measures to a very large extent the capacity of the cash flow stream to return the installment on the loan. And financial institutions are very concerned about this, and they normally sanction loans only when the debt service coverage ratio is greater than 1.5 or close to 2. Similarly, when you talk about risk evaluation in products, what really happens in risk is that there is uncertainty as far as the cash flows are concerned. So you don't know exactly whether your investment is going to be 5 lakhs or 6 lakhs, but you know that it could be within this range. Similarly, you know that your returns in the first year could be 2 lakhs or 2.5 lakhs, as the case may be. And similarly, you have ranges for each of the cash flows in various years. So you have essentially uncertain cash flows with some estimate of the degree of uncertainty that is likely to arise in each of these cash flows. Normally, what is done is that this kind of a situation is typically projected in terms of 2 or 3 different scenarios. You can talk about an optimistic scenario. Obviously, the most optimistic scenario would be when you'd have the least of cost and the maximum of returns throughout. Similarly, you can talk about a most likely scenario, which would be somewhere between the extremes, and then you can talk about a pessimistic scenario in which the costs would be high and the returns would be relatively low. And you can do the analysis on this basis. And quite often this kind of analysis, once it is made in terms of these scenarios, can be analyzed in terms of a decision tree. And a decision tree would have decision nodes where you can choose your course of action, and ultimately when you encounter a square node or a probabilistic node, you would face this uncertain option. So you would know the probabilities that you would land up on this branch or this branch, and so on for the tree. And the tree could then be evaluated in order to determine what the best strategy should be, and also to quantify the risk, because the risk is nothing but complete consideration of the probability distribution of outcomes corresponding to a particular strategy. So this is the manner in which we could completely talk about risk evaluation, which is a very major concern in the introduction of new products and services. Now, if we come to the topic of annual costs within a project, typically what happens in the profit consideration for any company is that costs are typically built up of a number of layers. And these layers are, for instance, you might have a setup cost, setup for the various machines. You might have a cost of materials which you procure for production. You have a cost of labor. Then you have overheads on these costs. Then you have costs of storage. Then you have costs of distribution. So these are the various layers which are there, and so this total cost up to here is the total cost of the product, assuming for the time being that I am plotting quantity this side and the cost or profit on this axis, what really happens is that if this is my selling price in terms of the product that I am trying to sell, the difference between the selling price and the total cost will in fact give me the profit margin per piece. So it's in fact the profit rectangle here that you see on the top which management is most concerned about. So let's look at this profit rectangle in greater detail. Let's look at this profit rectangle here. In fact, the objective of most companies is to increase the area of this rectangle. And isn't it quite surprising that most production managers and other CEOs of the company are actually hired to basically maximize the area of this particular profit rectangle, right? So let us see, if we were to maximize the profit, because that is one of the major concerns of the organization, what are the strategies that it can follow? Well, you can think of basically three pure strategies. You could talk about strategy A, which means increase the selling price. Now, if you increase the selling price, the top line would go up, and therefore you expect the area, that is the total profit, would go up. But this is not a very good strategy. Why is it not a good strategy? It's not a good strategy because if it's a competitive world like it is today, the chances are that you would lose out on sales. Your market share would tend to drop if you increase the selling price. So what will happen is that this side of the profit rectangle will tend to fall. So what may happen, what started out as an exercise in increasing profits may in fact land up into an exercise in reducing profits, and therefore this is not a good strategy, although this strategy would work well in a situation where there is a monopoly. So if people are forced to buy your products, then you can keep on increasing the selling price as much as you want, and there is no competition, and therefore this kind of movement of the sideline to the left would not take place. But in general, this would not be a good strategy. Let's look at the case B. If we try to increase the market, how do you typically try to increase the market?
So one way can be to reduce the selling price.
Yes, one way can be to reduce the selling price. Very true.
Advertisement.
Advertisement could be another way. You put in greater advertisements. You offer greater incentives.
So variety.
You start. Yes, if you're talking about variety, it could be variety, but we're talking about, let's say, a particular product. So if you introduce variety, maybe the profit would be shared between the two products. So that also may not work well. So this will be a costly proposition to some extent. So all this would lead to is, so if this could be done in isolation, it would be a good strategy. But what happens is, the costs at various levels, the costs of distribution, the overheads and other things, the account that you'll offer, it will tend to increase the cost, and this portion will try to move up. And therefore, this strategy would be worthwhile only if the increase in sales more than compensates for the increase in additional costs of advertisement and offering discounts and things of that kind. Isn't it?
So mergers would also be a strategy. So mergers and acquisitions.
Yes, mergers and acquisitions could be there, but here we are talking about a particular product. Merger and acquisition would essentially help in reducing competition, isn't it? That's all. That's what will happen. Take strategy C. Strategy C says reduce the total cost. That means if you look into your own operations and try to cut down costs wherever there is a flab, cut down, make distribution more effective, make storage more effective, make overheads, reduce the overheads, cut down costs of labor by providing better methods. cut down costs of materials by better designs, cut down the setup with better machines and things of that kind. If you do that, then you would definitely have a situation where the costs would go down. And if costs go down, there is no negative effect on either the selling price or the market force, isn't it? So whatever you gain in terms of the selling price tends to be a bigger rectangle here, and you are directly heading for, it's a riskless strategy which will lead to increased profits, isn't it? In fact, if you look at the situation of the American auto market and you see how Toyota entered the American auto market, what did they do? They actually played with this strategy C. What did they find? They found that they could reduce the prices by virtue of their better quality control and other things, and bring down costs. So they were much more competitive as compared to the American auto manufacturers. So a lot of people started shifting to the Japanese cars, that is Toyota and others in that sense. And when they shifted like this, the profit went up. Now, Toyota did another interesting thing. They said that when this profit margin was increased, they passed on the benefits of this increased profit margin to the customer. That means they lowered the selling price of their cars further. If this had gone down by 100%, they would bring this down, let's say, by 50%, something like that. So as a consequence, their market sales went up even further, and there came a time when they dominated the American market, and General Motors and Ford Motor Company were at a loss because they didn't know what to do. So it was basically the operation of this kind of a strategy C, followed by passing on the benefits to the customer, that is reducing the selling price. Reducing the selling price if you cut down your costs, and in that manner the sales increased tremendously and they could increase their profits. So some very interesting strategies to increase the profit depending upon the situation at hand could be thought out by looking at this profit rectangle and seeing what could be done under the various circumstances in that sense of the term. We can define a term called the competitiveness of a product. Any product, we define competitiveness, and competitiveness is nothing but the fraction of the market captured by the product. So if this is the total market for a certain product, which is denoted by a volume P, the small p is the value that the product captures, then P by P will be a ratio which will lie between 0 and 1, which will give you an idea of the fraction of the market that is being captured by the product, and this is defined as the competitiveness of the product. And how do you increase the competitiveness of a product? The major thing is you want your products to compete in the market and do very well. So how does that happen? In fact, it is this ratio of value to price that determines the competitiveness of a product. So if a product has lower price and a higher value, what is value? Value is the subjective estimate of the worth of a product that the consumer perceives for your product. Right? So if your product offers greater value for a lesser price, this ratio to a very large extent then determines the competitiveness. So which are the major parameters that companies can play with in order to capture markets and in order to introduce products? They try to make sure that the value has increased. We already talked about in the last lecture about the various tools at the disposal of a product designer. We talked about QFD, we talked about value engineering. So all these tools will in fact are all designed to increase the value of the product. And of course the price. How do you reduce the price of the product? By making sure that there is less of waste, there is better quality, and things of this kind. So constantly examine yourself to lower down your prices. That's what you're trying to do. And that's becoming more and more important in today's competitive world. If you have to survive in the market of today, you have to increase your value and cut down your prices somehow. And that's what is important every day. This is happening in everyday fields, right? So for instance, in today's newspaper, I was looking at an advertisement for a trip to Europe. About 10 days ago, this trip to Europe was being offered by a company called SOTC for about $1,700 for a 15-day trip. And the advertisement in today's paper was that this would be a trip for about $1,300 for a 15-day trip with an overnight stay in Dubai and 5-day stay in Switzerland. What is this that they're doing? So we are talking in this class about designing products and services. So I've given you an example of a design of a service by SOTC, which is a package for tourism, and which is also based on this concept of increasing value and reducing price to capture more and more customers. In that sense. Let us now talk about a very fundamental concept of fixed and variable costs in the context of new products and new services. The distinction between fixed costs and variable costs. Well, I think it is obvious that fixed costs are generally those costs which do not depend upon production volume. So it's like saying the basic infrastructure of a factory, the cost that you have for maintaining that infrastructure, the rental that you pay for the buildings, the other expenses that you have to incur for just maintaining the building, those costs you will incur no matter whether the factory produces any item or not. Okay? So those are the costs which we call fixed costs. And these costs which must be incurred no matter whether we produce or not. Some typical examples of these costs are rental or cost of land, the initial machinery cost, the management and indirect salaries, the warehouse, factory and office space. Costs for these will typically depend upon what we call fixed costs. And when you talk about variable costs, you're talking about costs which directly depend upon production volumes, such as raw materials. So if you're talking about Maruti Udyog Limited, the cost of steel which goes into as raw material for their stamping division to make the bodies is directly dependent upon the number of cars produced. Okay? So raw materials of all kinds. Utilities, direct labor. It's like saying that 5 men are needed to make, 5 man hours are needed to make 1 car, and therefore for 2 cars you require 10 man hours. So that's a variable cost in that sense. Packaging cost, shipment cost, all these are essentially. In fact, what would happen is typically various costs would have a fixed component and a variable component. And to some extent, the manner in which a company defines its fixed cost could be arbitrary. But you must understand that this is defined dependent upon the purpose. For instance, it may so happen that a company spends, let's say, 80,000 rupees on a certain machine today. It might decide that the 80,000 rupees is to be recovered in this very year. Then 80,000 rupees will be a fixed cost in this very year for this particular machine. On the contrary, the company might say, okay, this 80,000 rupees, we would like it to be recovered over 2 years and say 40,000 rupees each. In that case, the fixed cost that would be allocated would be 40,000 rupees each year for 2 years in that sense. Okay? So that is the way that fixed costs and variable costs could be considered. And to some extent, the allocation of the total fixed cost to the number of years is a decision which is taken by the company depending upon its own circumstances and its own objectives. A very useful and a very simple analysis which can lead to a lot of useful insights into about how the company is operating can be done through what is called a break-even analysis. A break-even analysis is nothing but a plot of the cost or revenue on the y-axis and the volume of sales on the x-axis. So what may happen is really that if my fixed costs are F, I would say, for instance, that my fixed costs are F. So I would put the fixed cost F here, and the total cost would be this line here. So the total cost is the fixed cost plus AV, where A is the unit variable cost. So the way we have defined it, A would be nothing but the slope of this line. This is A. So F plus AV is the total cost line, and as we have as a function of volume, as the volume keeps on increasing, the cost would keep on increasing. Let's look at the revenue function. The revenue function is typically given by BV, where B is the selling price per piece and V is the volume of sales. So in this particular situation, we would have this particular slope of this line is B, which is the unit selling price, and we have now here. Now from this diagram you can easily see that the point of intersection of the total cost and the revenue, that means at this point, the point V1, the total cost is equal to the total revenue, so there is no profit or no loss. And if you operate in this region, you are actually incurring this much loss, and if you operate in this region, you are incurring a profit in this region. So obviously any company would have a desire to operate only to the right of the break-even point and not to the left of the break-even point. So one can easily determine the break-even point by equating the revenue and the cost. So the revenue is BV1 and the cost is F plus AV1, which is actually V1 is the break-even point. So we can see that V1 is equal to F upon B minus A. This gives us some good insights into how we can manipulate our break-even point. What would happen if our intention is to lower the break-even point, which is V1? What are the strategies that a company can adopt to lower the break-even point? Because companies would like to operate at as low a break-even point as possible, so that the range of operation as far as profits are concerned is increased. So this expression simply tells you that there are only three ways to reduce the break-even point. You can reduce the fixed costs, or you can increase the unit selling price, or you can reduce the unit variable cost. So in that sense, you can find out what the break-even point is going to be. Now break-even analysis can answer a number of questions. For instance, what may happen is that if this is the break-even point for a company, for a product, and suppose I am operating at a point V2, what would be the implication of this? The implication is the further to the right I am of the break-even point, the better it is for me. Okay? So we define a concept called the margin of safety. The margin of safety of operation, if you are operating at V2, is just V2 minus V1 divided by V1, which is nothing but V2 by V1 minus 1. So in fact, at any point of operation, you can calculate a margin of safety, and this would give you an idea of how safe you are in terms of operation. Because what happens in real life is that these volumes of sales are highly dynamic in nature, and they could be fluctuating up and down, so on. The higher the margin of safety, the safer you are from such violations or such disturbances which tend to take place in these kinds of systems. In the break-even analysis, we talked only about the costs and the revenues. Quite often, a manager's concern is with profits, right? So, an alternate variation or an alternate representation of the same information can be made through a profit volume chart. So, we are going to see here what a profit volume chart looks like and how it is derived. The profit Z at any particular point of time is nothing but the difference between the revenue and the cost. Okay? And we have seen that the revenue is BV for any volume of sales minus the fixed cost, which is F plus AV. So, this can be directly written as minus F plus B minus A into V. Now, this is nothing but the equation of a straight line, right? And this equation of the straight line, if we denote B minus A by a constant P, we can simply say minus F plus PV, where P is the slope of the line and minus F is the intercept on the y-axis. So, if you plot the profit versus the volume, the same information that we had in the break-even analysis would show that the profit function is a straight line with an intercept of minus F here. A slope of this line is equal to B minus A, which is P, often known as the profitability. This is how we formally define profitability of a product. And we would see that this particular point where the volume corresponding to which the profit is 0 is defined as the break-even point. So, that point is V1 here. V1 is the volume of sales, and this is the equation of the profit volume chart. So, we are relating the profit directly to the volume of sales. This is a constant and this is a constant. This is the fixed cost, the negative of the fixed cost, which has to be recovered. That is why up to this volume you have no profit, because you are recovering the fixed cost essentially. And at this point of time onwards you have profits which are positive and in this sense. Now, why do you think this difference between B minus A is called the profitability? What is the physical or the managerial significance of profitability? See, profitability here is the slope of the profit volume curve, the profit volume line. So, the interpretation of profitability is the increase in profit per unit increase in volume of sales, right, in that sense. So, that is why it is called profitability. And what does it depend upon? Suppose a company was to do an exercise in improving its profitability. What are the kinds of things that it will have to do? It has to basically increase B and reduce A. What does that mean in physical terms? If a product has to improve in terms of its profitability, P means selling price. Selling price has to increase, not has to increase, could increase. You could keep it constant and still reduce A and thereby increase the profitability, which is the better option in many instances. But if B increases and A reduces, so reduction of A is reduction of all your costs. So, whatever cost reduction you can bring about so that the total unit variable costs comes down, it will help in improving the profitability. And therefore, all kinds of projects that may be undertaken in companies which are looking at waste reduction, improval of processes and so on, they are all basically aimed at reducing the total costs in that sense. Of course, how do you increase B? How would you naturally like to increase B? You are selling your product, yes?
So you would have to add features to the product.
That's right. You would have to add some features to the product. So what would that mean? That means it would increase the value of the product to some extent. You have better features, so you are willing to pay more for those features. Yes, please.
Or if you manage to profile and position your product as a luxury product, you might be able to increase the price by 400% or similar, and you will take it to another level.
That's right. So what our friend is pointing out here is that for luxury products, which essentially have a tremendous amount of margin in terms of their pricing, you could increase B to such an extent that it could maybe belong to a totally different category. But that again is possible only if you add some features to it, if you make it better. Right? For instance, if you're talking about marketing towels for the Goa beach or something of that kind, what would be required of those towels? Basically, it would be the same Hindustan Lever towel or some other towel, but some kind of features would have to be added, like maybe you have some kind of small, you can say, picture of the beach or something of the kind on something written on the towel and saying that this is the exclusive club of Bombay or something like that, or whatever it is. So you have to do something to it. So the point really is that if you have to improve profitability, you are right, but even to take it from one level to another, you have to do something. And what is that something? Increasing value by providing some additional features. And what can happen is that you can put in those features which appeal best to a certain class of people. Then for that class of people, you have enhanced the value of the product and therefore gone up much more. So the point that we are simply trying to look at here is that profitability is a very important concept, and normally companies are striving to improve profitability. And what we are trying to see is what could be the possible mechanisms that could be there for increasing profitability. That's, I think, what is really important. And what would happen if you increase profitability is the slope of the line would increase. The slope of this line would increase. That's what it is. Let us now take an example. And this is an example of a situation where a management can choose between 3 products. So the management choices are to choose either product A or product B or product C. And for the sake of simplicity, we are assuming here that the fixed cost for these various products, the unit variable cost for these products, the likely sales for these products, and the selling price for these products. What is being assumed here is that the likely selling price for each of these products is the same. That means we are essentially buying or procuring these products from different sources, and we are able to earn the same amount of revenue on each of them, but our costs and the capacities of the individual suppliers vary considerably as far as these 3 products are concerned. So what we would like to do is to do an analysis and find out what particular choice the management should make and how it should go about making this choice. So what you find here is that product A, there is no fixed cost. So it's like directly buying the product per piece, and you can buy the product for 100 rupees a piece, and the vendor for this particular product is capable of supplying to you only 1,000 pieces in a particular period, and you can sell the product for 150 in that case. Similarly, product B requires that you set up something, so you're required to make an investment to the tune of 10,000 rupees, and the unit variable cost has come down from 100 to 80 rupees, and you can go up to a volume of 2,000. The likely sales are 2,000, which means essentially the implicit assumption is that we can go up to this particular level, because beyond this we are not likely to sell of this particular item. Product C, the investment gets doubled and the unit variable cost comes down considerably. It's now only 50 rupees a piece, and we can go up to 5,000 rupees and the selling price is 150,000. What we'll try to do is we'll try to draw for this particular situation the profit volume charts for individual products and see how different ranges give us different opportunities and how exactly we can determine the best opportunity for different types of products. The first thing that could possibly be done in this example is that one can compute the profit functions of the three products A, B and C. It's very simple. The profit function is minus F plus B minus A into V. So if you write that down for the individual product, this had a 0 fixed cost, B was 150, unit selling price is 100 rupees. So this is just 50V. That's what it is. So it's a straight line passing through the origin with a slope equal to 50. The profitability is 50 for this particular product, and obviously the break-even point for this product is 0. Similarly, for the second product, minus 100,000 plus 150 minus 80 into V. So we develop the profit function for the second product, which is minus 100,000 plus 70V, and this has a break-even point of 1429. You know, if you recall, the break-even point is simply computed as F over B minus A. So we are given F, which is 1 lakh, and B minus A is this volume, so we directly get the break-even point. Similarly, for ZC, we have minus 200,000, 150 minus 50 into V, and so the equation for the profit function is minus 200,000 plus 100V, and the break-even point for this particular product will be 2,000. Just to draw the graph more conveniently, we can perform these computations. We can find out the break-even profit values occur. There are only 3 products, A, B and C. So the intersection of 2 lines, there can be at most 3 possible intersections. So between A and B, B and C, and C and A. We know the profit functions. So we equate the profit functions, and we find that for A and B, at a profit value of 2,50,000 rupees, the volume is 5,000. For a volume of 3,333, the profit value is 133,310. And for C and A, the break even will be volume of 4,000 and a profit value of 2 lakhs of rupees, as shown here. Now, armed with this information, it's very easy for us now to draw the profit volume charts to scale. And the profit volume charts now for the 3 products are shown here. This is for A, this is for B, and this is for C. Product A had no fixed cost. Product B had a fixed cost of 1 lakh of rupees. Product C had a fixed cost of 2 lakhs of rupees. And correspondingly, all these break-even points have been computed, and these are now drawn to scale in this particular graph. And this is now our objective. What is our objective? Overall objective. Our overall objective is that if this is the volume of sales in thousands of units, and these are profits, we want to maximize the profit. That means we want to take the topmost envelope of these curves, which will maximize the profit function. That's what we are interested in. So for this particular situation, what you find is that for volumes up to 4,000, clearly product A is the dominant product, isn't it? It's the highest profit as compared to the others up to 4,000, and beyond 4,000 the best is to go in for product C. And as far as product B is concerned, it is being dominated by either A or C, as the case may be. So our situation is that product A will yield a maximum profit if we go up to 4,000. Yes, we'll address your question after I finish the I'll show you the second chart. Maybe your question will be answered there. And then beyond that, what you find is that beyond 4,000, so A is the best option if you are in this range, and V is the best option if you are in this range. Obviously, so this is the global objective, but in this case we had not taken into consideration the various constraints on quantities that we said we could do. So let's try to take the constraints on quantities. What you find here is that A and then B and then C, what has happened is that product A, if you look at the data, product A likely sales go up to 1000. So if we assume that this particular option is available from 0 to 1000, this option is available from 0 to 2000, and this option is available from 0 to 5000 only, then what is going to happen? So what you find is, in this case, since A is available only up to 1000, so this option will be available only by the dark line here, only up to this particular point. And thereafter the maximum profit would occur corresponding to the option of the product B. So this product B would go up to only 2000 because this option is not available after 2000. And then the third product, which is product C, it is lower here, but is still lower than this, but this is not available now. So from 2000 onwards up to 5000, that means here. So now what's happening is that if we assume the limited capacities for the various products, our decision situation for the optimal product now is this is our optimal situation, that product A lies between 0 to 1000. If you want to, the best is to use option A. Between 1000 and 2000 use product B, and between 2000 to 5000 use product C. So this decision obviously is different from the decision that we had earlier about the global situation where we had not considered the various. Does that answer your question, please? It does. Okay. Any more queries here? Any observations at this stage? So what you see is that a simple break-even analysis or a simple analysis of the profit volume chart, which is actually the same thing in different words, can answer very important decisions regarding the optimal choice of strategy for introducing different types of products at different in different ranges of volumes of sales. And I think this is a very important contribution of this whole concept of break-even analysis and profit volume charts. Another important concept which occurs in product design is the notion of modular design. When you talk about modular design, we say that products are typically designed and manufactured in modules. Why? This results in various advantages. Some of the advantages are there is low cost of production if products are produced in modules. Okay? The modules would be like for a car, you have the engine, you have the carburetor, you have the brake assembly and so on. So these are actually individual modules and the whole production takes place module wise. There could be greater product variety at low cost. This is one of the major advantages of modular design. There could be greater satisfaction for assembly workers. Why? Why should there be greater satisfaction for assembly workers? Simply because a worker now assembles the entire module. So he has the satisfaction of producing an entire carburetor. Right? It's not like saying that they say when a man retired on the Ford assembly line, he was asked, what did you do? He says, I tightened bolt number 999 on the Ford assembly line for my entire life. Now what a boring life it would have been. But at least now he has the option of saying and telling his wife that I have assembled all the carburetors that you see on the Mercedes, something of that kind. That's the idea. There's a greater choice of subcontractors and vendors for product manufacture, and control of product reliability and cost can be made easier. So we'll take a small example of modular design and see how we work with modular design. Suppose there is a component which has two subcomponents A and B, and we are assuming that for the component to function, both A and B must function. If any one fails or both fail, then the product is a failure, right? So if there are 3 designs for A and 3 designs for B, what would happen? There is a total of 9 designs for the product. So just by taking a limited number of designs for one module and a certain number of designs for another module, you can generate a large number of product variety. So this is how typically the Japanese cycle manufacturing companies, that's how they operate. Because what they do is, a person goes and get a personalized bicycle. So they take his dimensions, like you are stitching a suit, and they make a bicycle to your dimensions and give you, let's say, after 36 hours or whatever it is. How this happens is that for each of the modules, they have the frame module, they have the they have the wheel module, and so on. All they have to do is to put together the various modules and generate the size which they want to generate for that particular individual. So this is basically the concept of modular design. Let's look at a small example. This very example, where there are 2 components A and B, and let us say that the reliability of these components can vary from 0.9 to 0.95 to 0.98. So increasing reliability is like saying better quality you are getting. And the costs that are being available for these things, you can imagine that this is like a vendor 1, this is like a vendor 2, this is like a vendor 3, who is providing these components A and B. So he offers, vendor 1 gives you this reliability for 50 rupees and this particular reliability for component for 70 rupees. For 95% reliability, the same information is that 90 rupees will be the cost of A and 90 for B. So he's supplying both the products at the same cost. And this one is providing a reliability of 0.98 for 140 and 110. Now suppose the required reliability of the product is 90%. This is the requirement of the design, or it could be a requirement of the marketplace, whatever it is, you want to do this. The question is, how would you buy the components from different vendors so that you can attain this reliability at a minimum cost? It's a small example. We can do the whole thing by enumeration. What would happen is that there are 9 combinations involved, and you can have 0.9 reliability, 0.95 reliability, 0.98 reliability for the subcomponent A, and the corresponding costs are listed here. And similarly for B, you can have reliability for each of them of 0.9, 0.95, 0.98. So you have all the combinations, and similarly you have all these probabilities here, and the costs are here. So what we can do is we can calculate the reliability of the product. The reliability is multiplicative, right? So the reliability of the product is 0.9 into 0.9, which is 0.81, and the costs are additive, right? So this is 120. This is the cost. We can do the whole thing for the entire thing. We are interested in a product reliability of 0.90. Obviously these are not feasible, all these designs. This is the first feasible design, 0.9025. There are higher values of reliability available, but we get this, and this particular value gives me a total cost of 180. So of all the possible designs, it is this combination 5, which is shown in bold here, is the optimal one, because I can now generate the new product at a total cost of 180 and get a required product reliability of 0.9025. So this kind of analysis is very easily possible when one is thinking in terms of modular design. So you can work out the reliability and cost implications of individual designs and try to determine the best design in that particular context. Finally, let us try to summarize what we have tried to do in this particular lecture. We have seen, for instance, that as far as the financial evaluation of products, which is generally carried out in 2 phases, The first phase is the phase where we talk about gross measures of evaluation, and here we are talking about the net present value determination, the internal rate of return, the payback, the risk, and the financial ratios. And these are some things that we had already discussed when we were talking about the financial evaluation of capital investments in a previous lecture. In this particular lecture, we have tended to focus more on the annual cost analysis, such as break-even analysis, profit volume charts, profitability, and the effect of fluctuations in demand and profitability on the product. So what we saw was that profit volume charts could be used to determine the optimal strategy when choices are available. That was one interesting thing. And secondly, we had looked at the notion of modular design which helps to improve variety, lower costs, and results in greater job satisfaction to workers. In fact, we had taken an example in which we had seen how different combinations could be evaluated, and ultimately you could determine the best possible design. In our next lecture, we shall be talking about the aspect of the optimal product mix. That means a company generally manufactures not only a single product but a combination of products. What should be the possible mix of these products so as to maximize profits? And there are many mathematical models available for dealing with this problem depending upon the situation. So we look at the deterministic as well as the stochastic aspects of this particular problem next time. Thank you.